Your average everyday void is pretty dull by and large, and standing alone in the middle of it doesn't lead anywhere much at all, even when a man standing there knows all about points, lines, and figures. Knowing how to measure them doesn't help much either, at least after the first blush of excitement has passed. But beyond the void, there are worlds of beauty and worlds of wonder. Somehow, a man must find them. A man must move. A basic movement in geometry, and a good place for a man to start, is called rigid motion. Rigid motion results when a line or a plane figure is moved without changing its shape or size. A rigid motion moves a line segment into a congruent line segment. A congruent line has the same length. Congruent figures have the same size and shape. A rigid motion moves a triangle into a congruent triangle. In particular, if triangle ABC is flipped through a third dimension around line AB, triangle ABC prime is the same size and shape as triangle ABC and is congruent to it. The segment CC prime is perpendicular to the line AB. And the segments CD and C prime D have equal lengths. This type of rigid motion is called a reflection, and consists of the reflection of a plane about a line. In general, a reflection takes any point P on one side of the line into a point P prime on the other side, such that P prime is perpendicular to the line, and segments PQ and P prime Q have equal lengths. Thus, to take another example, triangle XYZ can be taken into triangle X prime Y prime Z prime through a reflection. Since all lengths are preserved, triangle X prime Y prime Z prime is congruent to triangle XYZ. In a reflection about a line, a clockwise rotation goes into a counterclockwise rotation. Every time a reflection about a line sends a geometric figure into itself, the line is a line of symmetry of the figure. When two congruent triangles are located like this on a plane, one of them can be slid into the other. This type of rigid motion is called a translation. Lines drawn between points Q and Q prime, R and R prime, and S prime are parallel to the line of translation. To be specific, a translation preserves distance, takes lines into parallel lines, and figures into congruent figures. In contrast to a reflection, A translation sends clockwise motion into more clockwise motion. It is important to note that a translation may be obtained as the result of two reflections about parallel lines perpendicular to the direction of translation, one after the other. Rotation is yet another type of rigid motion. When two congruent triangles are located around a point of reference, one of them can be rotated around the point into the other. In general, rotation about a point moves each point P through a fixed angle along the arc of a circle, which could be drawn about the center of rotation. Like a translation, a rotation preserves distances and takes triangles into congruent triangles. Just as a translation can be made using two reflections about parallel lines, a rotation can result from two reflections, one after the other, about intersecting lines. Reflections, translations, and rotations are all examples of rigid motions which preserve distance. Any rigid motion can be obtained as a sequence of, at most, three of these. However, inconveniently enough, all figures are not the same size. When two triangles, for example, have the same shape, but not the same size, one being small and the other large, they are not congruent. Instead, they are called similar triangles. But stretching the small triangle the same amount in all directions will expand it until it is the same size as the large one. After this uniform stretch, they are congruent triangles. When two triangles are congruent, of course, they can be put through the various rigid motions. Rigid motion and uniform stretches form the foundation of the Euclidean geometry of the plane.